In this example, we're going to simplify this radical. So notice you have the negative out front. So keep in mind that that is nothing more than simply solving what's in front of the negative. And then remember when you present your answer that you have that negative there. So we're going to first proceed by simplifying 32. 32 is not a perfect square. However, it does have a perfect inside of it because 16 times 2 is 32 and 16 is the perfect. So now you're going to solve the perfect and it's going to go outside in front of the radical. So right behind the negative sign. And the 2 is not perfect, so it's going to have to stay underneath the radical symbol. So that's going to leave me with an answer of -4 radical 2, and that is choice B. In this example, we're going to simplify a radical expression. We're asked to simplify the cube root of -64, a to the 8th power, b to the 12th power. So the first thing we want to look at is the coefficient under the radical. We have -64. Is -64 a perfect cube root? If you said yes, that is correct. So the answer choice of E can be eliminated because this will result in a real number. Okay, so I'm looking for a number that when I multiply it 3 times will equal -64. Can you think of what that number is? If you said -4, that's correct, because if you multiply the number -4 3 times is going to equal -64. Now let's move on to our variables. Recall that variables are perfect if they are divisible by their index. In this radical problem or radical expression, the index is 3. The index is the same as its root. So all variables, their exponents, must be divisible by their index in order for them to be perfect. Now, if they are not originally perfect, if they're larger than the index, you can make them perfect. You may have to go down until you find a number that is divisible by that index. So let's begin with A. We have a to the 8th power, and 8 is not divisible by 3. So that means we have to go down until we find a number that's divisible by 3. Well, if we go down by 1, we have 7, and 7 is not divisible by 3 either. Let's go down one more. If we go down to 6, we have a number that is divisible by the index of 3. So it's going to wind up being a to the 6th power. Now, I still have a total of 8 A's, but I can only make 6 of them perfect, which means 2 of them will have to remain underneath the radical symbol because it is not perfect. Let's move on to our B. B to the 12th power, 12 is divisible by its index of 3, so therefore the B to the 12th power is already perfect. So I'm going to rewrite it just so you can see what I'm trying to explain here. You want to think of getting your perfect together because you want to solve that perfect, and it's going to go outside. And the non-perfect, we only have just the a squared is the only thing that's non-perfect. It has to remain underneath the radical symbol. So when we go ahead and solve the perfect and move it out front, it's going to give us a final answer of -4 a squared b to the 4th power cube root of a squared. And that is answer choice A. In this example, we're going to simplify a radical that contains a fraction. Anytime you have a radical where a fraction is underneath, that root applies to both the top and the bottom of that number. In other words, it's going to be the fourth root of 16 and also the fourth root of 81. So just think of them individually and just simply solve it. For the top, you want to know what number when you multiply it 4 times is going to give you 16. That number is 2. On the bottom, what number when you multiply it 4 times is going to give you 81. And that number is 3. So it is 2/3. Answer choice D. In this example, we're going to simplify a radical that has a rational exponent. So anytime your base of your number has a fraction for its exponent, you can rewrite that as a radical. So underneath the radical symbol, you're going to have your big number, your base of 16. And in terms of the fraction, remember what their meanings are. The top of the fraction stands for the power. The bottom of the fraction always stands for the root. And since the bottom of this fraction has a 4, that means that I'm going to write a fourth root radical that is going to be raised to the 5th power on top. So here we go. I'm going to go ahead and write it. My big number underneath the radical is going to be the 16. So that's fourth root of 16, and then raise that to the 5th power. So now all I need to do is solve inside the parentheses to find the fourth root of 16. I want to know what number when I multiply it 4 times will equal 16. And that number is 2. So next, I'm going to have to raise 2 to the 5th power. In other words, multiply the number 2 5 times. And that will give me an answer of 32. And there you have it, choice C, 32. In this example, we're going to simplify 2 radicals that are being multiplied. We're going to simplify it using rational exponents. So the first step we're going to do is to convert these radicals to a fraction exponent. So recall that on top is going to be the power, on bottom is the root. So if we take a look at the first radical, x is raised to the 5th power, so on top of my fraction you're going to have a 5. The root is third root or cube root, so you're going to have a 3 under the bottom. So this, to turn it into a fraction, is going to be x to the 5/3 power. On the second radical, it is not raised to any power here, so that's when it's not raised to a power, we use 1 as its power, because anytime you raise something to the 1 power, it does not change the value of it. So the top of the fraction for the second expression will be 1. For the bottom, the root, that's a 5th root. So that's going to be x raised to the 1/5 power. And now that we have converted them to a rational exponent form, next we're going to apply the product rule, which states that if the base is the same, keep the base and add the exponents. And here we can see the base of x is the same, so keep the x and add the exponents. Now these 2 exponents happen to be unlike fractions, so you're going to have to find the LCD in this case, which is 15, and multiply each fraction with what it needs to be the LCD. I'm not going to go through that whole process because at this point you should be able to add unlike fractions on your own. So when I add these unlike fractions, it's going to leave me with an answer of 28 over 15, and that is choice C. In this example, you're going to simply take your scientific calculator and calculate the approximation of square root of 537.86 to the nearest hundredths place. In other words, leave 2 decimal places up. So if you go ahead and type that into your calculator, you should get the following approximation. And leaving just 2 decimal places up, what you do is you go to the third place to see if that third number there, if it's 5 or more, it would make the next number in front of it 1 more. But since it's less than 5, we drop it and everything behind it. So from the 1 and behind, you're going to drop all of that, and it leaves you with an answer choice there of B, 23.19. In this example, we're going to simplify this rational exponent. Recall that you cannot have negative exponents, so what you're going to have to do is to flip it. So if you have a whole number, such as this is a whole number of 64, if you were to write it as a fraction, it would be 64 over 1. But then you still have to flip it because of the negative fraction there. You cannot have a negative exponent. So whatever is on the bottom is going to go on top. So the 1 is going to come on top, and the 64 is going to go to the bottom. Once you do that flipping process and you write it as its reciprocal, the exponent will then become positive. Next, you need to remember that whole power over the root. Whatever's on top is your power. Whatever's on the bottom is your root. So when I rewrite this as a radical, I'm going to write it as cube root, and then I'm going to raise it to the second power, or in other words, square it. So let's go ahead and write this radical, this fraction of 164 in radical form with cube root, and then raise it to the second power. In other words, square it. So solving just inside the radical, the cube root of 1 over 64 is 1/4. Next, I'm going to square 1/4. When I square 1/4, you should know that that's the same thing as saying 1/4 times 1/4, which is going to give you 1/16, and that is answer choice C. In this example, we're going to simplify the square root of 48x to the 12th power, y to the 5th power. Well, first of all, starting with the coefficient of 48, 48 is not a perfect square. However, it does have a perfect inside of it, because 16 times 3 is 48, and 16 would be the perfect. Let's look at the variables. X to the 12th power. By the way, what is the index of square root? If you said 2, that is correct. Now, you'll never see the 2 out there in probably any textbooks that you'll see. It's never written there, but it's understood and assumed that when you don't see an index outside a number, that it is square root and it has an index of 2. And since x to the 12th power is divisible by 2, the x to the 12th power is a perfect square root. How about y to the 5th power? Is that a perfect square root? No, because 5 is not divisible by the index of 2. Now, if you go down 1 and write it as 4, y to the 4th power, then it will be a perfect square. However, you have 5 y's, which means 1 y is going to wind up being left behind under the radical symbol. So what you're going to have is the 3 and the y are the non-perfects. So it's going to be left under the radical. The other part is all perfect. We can solve that, and it's going to go out front. So let's see what's going to go out front. The square root of 16, yes, it's 4. The square root of x to the 12th power, so 12 divided by 2, that's going to give me x to the 6th power outside. The square root of y to the 4th power, yes, you got it. It's going to be y squared outside. So when you're done, your answer should be 4x to the 6th power, y squared, radical 3y, because the 3y has to remain underneath the radical symbol. And that's going to leave me with an answer choice of A is the correct answer. In this example, we're going to add radicals. Now, notice the number underneath the radical, which is called the radicand. They're different, so you cannot add them the way they are. Besides, you can't add them the way they are also because one of them, the first one, is going to produce a real number. The other is going to produce an imaginary number. The other one is not a real number. So all you can do is to take each one of them and simplify them as much as you can. And let's start with the first one. 45 is not a perfect square. However, it does have a perfect inside of it because 9 times 5 is 45. So 9 would be your perfect square root and 5 would have to remain underneath the symbol. And looking at negative 98 again, that's not going to produce a real number here. But however, just looking at 98, the positive of that, I know that 49 times 2 is 98. So you're going to have a negative there. And remember that the square root of negative 1 equals I. So what you're going to wind up taking out is that negative, which is an I, and the square root of 49 is 7. So the 7 and the I is going to come outside, and the 2 has to remain under the symbol because it's not perfect. With the first expression, we can find the square root of 9. We know is 3. So 3 will come outside, and 5 has to remain under the symbol. So when we do that process, what it's going to leave us with is 3 radical 5 plus 7i radical 2, which is answer choice C. In this example, we're going to add and subtract radicals. First thing you should do is take a look at the radicand, which is the number underneath the radical symbol. For the first term, I have a 32. Second term, I have an 18. Last term, I have a 54. Since none are the same, they are not like radicands. So once you notice they are not like radicands, you have to then look inside to find the perfect inside each. So I'm going to go ahead and list the perfects that are inside those numbers. So in the first term, it had a perfect 16, second term, perfect 9, and the last term also had a perfect 9. So recall, for solving radicals, you're going to solve the perfect. It's going to go outside in front. Now, if there is a number already out front, when your number comes out, it will multiply with that number already out there. So let's start with the first one. The square root of 16 is 4. What do I do with that 4? Multiply it with the 3 on the outside. The square root of 9 is 3. What do I do with that 3? Multiply it with that negative 2 on the outside. So you're going to go ahead and do that process and multiply the numbers. So the first term is going to leave you with 12 radical 2, and then negative 6 radical 2. Next, notice that the radicands underneath the first two terms here are the same, so we call those like radicals, and with like radicals you can add or subtract them. So the rule is keep the radicand, which is the radical 2. On the outside, I'm going to subtract 12, take away 6. That's going to give me 6 radical 2 plus 3 radical 6. And at this point, you are done because the radicands are not the same. So that is the simplified answer, which is choice D. In this example, we're going to add and subtract radicals. So first of all, we want to look at the radicands. Underneath the radicand, the number under the symbol, they're all different, so they are not like radicals. So now we're going to find the perfects that are inside. Now this is cube root, so I need to identify all the perfects that are inside these numbers. So I'm going to go ahead and list them for each term. 8 times 3 is 24. 8 is the perfect cube. 27 times 3 is 81, and 27 is the perfect cube. Now 3 is the second term there. 3 is not a perfect cube, so it's going to have to just you're going to just leave it just the way it is. It's already in its simplified form. You cannot simplify that any further. But let's go ahead and simplify the first and last term. Starting with the first term, the cube root of 8 is 2. What am I going to do with that 2? Multiply it outside with that negative 2 to give you negative 4 outside. For the last term, the cube root of 27 is 3. What am I going to do with that 3? Multiply it with this negative 6 on the outside. So we'll go ahead and multiply them, and that's going to give us negative 4 cube root of 3, and then plus 5 cube root of 3 minus 18 cube root of 3. What do I notice here? Our radicands are the same for all 3 terms. And when they are the same, they're like radicands, we can go ahead and add or subtract them and keep the radicand of cube root of 3. So let's go outside and just combine the outside. So negative 4 plus 5 is going to give me 1. And then 1 minus 18 is going to give me negative 17 cube root of 3. Answer choice A. In this example, we're going to multiply 2 binomials that contain radicals. Anytime you have 2 binomials, you're going to have to use FOIL. FOIL stands for first, outer, inner, last. So let's begin that process, starting with the first terms. Remember, when you're multiplying radicals, you're outside with the outside and inside terms with the inside. Inside means underneath the radical. So outside first, 4 times 7 is going to give me 28. That's going to be outside. And then for the radicals, square root of 3 times square root of 3. 3 times 3 is 9, so that's going to be 28 square root of 9 for my first. Outer, outside, 4 times negative 2 equals negative 8. And then radical 3, so negative 8 radical 3. Inner terms, 5 times 7, 35 outside. And then radical 3. Last, positive 5 times negative 2 equals negative 10. After you do all the letters of FOIL, first, outer, inner, last, you're then going to combine outer and inner. Now we can also go ahead and solve this perfect square that's the first term. Square root of 9 is 3, and multiply it outside with that 28. But again, we're going to combine like terms of outer and inner. We always do that with FOIL, and the reason why is because outer and inner are like terms. And when you have like radicals, you keep the radicand of 3, and then we're going to combine the outside. A negative 8 combined with a positive 35 is going to give me positive 27. Notice we also went ahead and multiplied the 28 times 3, which gave us the 84. The last thing we can do with this is to combine the integers. Just keep in mind, be careful, don't combine anything with this 27 radical 3, because those consider them as one whole units. However, you can combine these two outer numbers, 84, take away 10, these integers, you can combine those to give you 74. So final answer then would be 74 plus 27 radical 3. Now, the most common mistake students make on solving radicals such as these is the desire or the want to add the two numbers here, and that would be incorrect if you were to add those two numbers and then say radical 3. You leave it the way it is. As far as can you have the 74 in the back, yes you can. You can also write your answer as 27 radical 3 plus 74. That's the same as well. But what you cannot do is combine these two numbers together. And so there you have it. Answer choice B. In this example, we're going to multiply two binomials that contains radicals. Now, there's something different about this set of binomials than in the previous example. Notice here the numbers that are in the binomials are the same for both binomials. The only difference that you see between the two binomials is its sign. One of them is negative and one of them is positive. When that's the case, you have what is called conjugates. And when you have conjugates, you really don't need to do all the letters of FOIL, first, outer, inner, last, that you normally would do with regular binomials. When you have conjugates, it is really only necessary to just do the F for the first and the L for last. So I'm going to show you that real quick and do that method. So if I do the F, multiply the first terms, 5 times 5 is 25. So I have 25 for F. Now I'm going to do L. Negative square root of 3 times positive square root of 3. That's going to give me negative square root of 9. And when I solve that, it's going to give me negative 3 for L. So now that I have negative 3 for L, I have 25 for F. 25, take away 3, leaves me with 22. And the answer choice is A, 22. Okay? Now, if you don't remember that, or if that just seems too complicated to have to remember, then fine, no worries. Let's go ahead and FOIL it. FOIL it by doing first, outer, inner, and then last. So when we do so, this is what we get. Notice that outer and inner are opposites of each other. They will always cancel out. And that is why I mean that you only have to do the F and L when you have conjugates, because that will always happen with conjugates. So here what we're left with is 25 minus 3, and then that gives you 22, which again, answer choice A. In this example, we're going to divide the radicals using rationalization. So first of all, looking at the radical here, we have a fraction underneath, and its square root. 3 is not a perfect square, and neither is 50. 50 is not a perfect square either. So What we're going to do, though, is we're going to take, there is a perfect inside of the 50 under the bottom, because when you think of it, 25 times 2 is 50, and 25 is your perfect. So let's take that perfect out of the bottom. That's going to be our first step. So when we solve the perfect of 25, square root of 25 is 5. So the 5 is going to go outside, and it's going to leave you with a 2 under the radical. So now we have on top radical 3, because you can't simplify that at this point. And on bottom, we've simplified it to 5 radical 2. Now, the reason you are not done with this problem is because there is a rule with radicals that you cannot have a radical left in the denominator. If you have a radical left in the denominator, your answer is not in its simplified form. So to get it in its simplified form, you're going to have to do a process called rationalization, to where you're going to have to multiply that root that you have with another like root to where it is perfect. In other words, on the bottom I have the square root of 2. So I have to look for another square root that I can multiply with that radical 2 that it becomes perfect, the smallest number possible. And I can think of a smaller number. That number would be 2. If I multiply radical 2 times radical 2, and by the way, whatever you do to the bottom, you have to also do to the top, that will produce a perfect root, a perfect square root, because square root of 2 times square root of 2 is square root of 4. That's perfect. And what is the square root of 4? That you got it. It's going to give me 2. Okay? Now, that's going to give me a 2 on the bottom. But on top, when I multiply those two radicals, radical 3 times radical 2, that's going to give me radical 6 on top. So I'm going to have radical 6 on top, and on the bottom I have 5 times 2. Because remember, we saw the square root of 4 gave me 2. Now on the bottom, all I have to do is multiply 5 times 2, which is giving me 10. And that is my simplified answer, radical 6 over 10. And now it is in its simplified form because it no longer has a radical in the denominator. So the answer choice is A. In this example, we're going to divide using rationalization. So whenever you have a binomial in the denominator and you need to rationalize, first of all, why do I have to rationalize? The reason why is because you have a radical in the denominator, and that's one of the restrictions of the radical rules, is that you cannot have a radical left in the denominator, otherwise your answer is not in its simplified form. So since I have a binomial, in order to get rid of that radical, I have to multiply by its conjugate. The conjugate of square root of 7 minus 2 would be its opposite, which is square root of 7 plus 2. Now recall the rules. Whatever you do to the bottom, you must also do to the top. So on top, I can just leave that as is. I have 4 times radical 7 plus 2. And on the bottom, guess what? I have conjugates. Remember what I said? If you have conjugates, all you have to do is do the F and the L. You don't have to do all the letters of FOIL, first and last. So that's going to give me 7 minus 4 on the bottom. And on top, as I said, you can just put it all together. Lastly, 7 take away 4 on the bottom is going to give me a denominator of 3. And there you have it. That is answer choice D, 4 times radical 7 plus 2 over 3. In this example, we're asked to find the distance between 2 points given. To find their distance, you will need to plug it into the distance formula. Recall the distance formula is where you're going to subtract your x's, square them, subtract your y's, square them. When you get it to where you have these two numbers, you're going to add those two numbers together. When you get it to where you have one number, you're then going to find the square root of it. So let's find out what each value is. So I have my first set of points, -3, -8, and my second set of points, 4, -1. So x sub 2 means of my second set of points, the number that is in x's place, and that is 4. X sub 1 is of my first set of points, the number that is in x place, which is -3. Y sub 2, it means of my second set of points, the value that is in y's place, which is -1. Y sub 1 is of my first points, the number that is in y's place, which is -8. When I plug those in, it's going to look like so. Remember, double negatives become positive. -3, but with a negative in front of it, becomes +3. -8, but with a negative in front of it, becomes +8. I'm going to go ahead and add these integers. 4 plus 3 is going to give me 7. -1 combined with +8 is going to give me 7. 7 squared equals 49. 49 and 49 is going to give me 98. 98 is not perfect, but it does have a perfect inside of it because 49 times 2 is 98. So 49 would be your perfect. The square root of 49 is 7. That's going to go on the outside, and the 2 is going to remain underneath the symbol to give me a simplified answer of 7 radical 2, which is answer choice D. In this example, we're going to use the Pythagorean theorem to find the exact length of side B in the figure below. So we're going to use the Pythagorean formula, which is a squared plus b squared equals c squared. So looking at the triangle that we are given, we know side A, it's 18. Side C, the long side, the hypotenuse, side C, the long side is always going to be side C. That's called the hypotenuse. It's 22. What we don't know is B. We don't know this particular side. So let's go ahead and plug in everything we know to find out what we don't know. When we plug those values in, it's going to look like so. Next, we need to square those, the 18 and the 22. So 18 squared and 22 squared is going to give us like so. Our next step to solving this equation is to do what? That's correct. Subtract 324 from each side because we want to get b squared by itself. Last step to solving this equation, to solve for b, you got it. We have to find the square root of each side. Once we take the square root of each side, we're going to also solve that square root. 160 is not a perfect square root, but it does have a perfect 16 inside, because 16 times 10 is 160. So let's solve that perfect square of 16. The square root of 16 is 4. That's going to go outside, and the 10 is going to remain underneath the symbol to give me a final answer of 4 radical 10, which is answer choice B. In this example, we're going to solve a radical equation. Step 1 to solving a radical equation is to make sure that the radical is isolated. So right now, positive 3 is on the side with the radical. So that's going to be our first step, is to get rid of that 3. So to do so, we're going to have to do the opposite, which is subtract 3. So let's go ahead and do that. We're going to subtract 3 from each side. That's going to leave me with square root of 3x plus 1 equals 4. And now that we have the radical on the side by itself as should be, we can proceed with the next step, and that is to get rid of the radical. Now, the only way you're going to get rid of that radical is to do the opposite. Opposite operations always cancels each other out or undo each other. So, the opposite of square root of a number is to square a number. So I need to square that left side. Now you know what the rules of equations are. Whatever you do to one side, you must also do to the other. So I'm going to take the square of both sides. By doing that process on the left side, I can now bring down the 3x plus 1 all by itself, because that has eliminated the radical and the parentheses. On the right side, I have 4 squared. 4 times 4, which is 16. I'm going to bring that down. What's my next step to solving this equation? That's correct. I need to subtract 1 from each side. Let's go ahead and do that. Last step to solving this equation is to do what? That's correct. Divide by 3, and x equals, you got it, 5. Now the one thing that you have to remember when solving radical equations is that you have to plug your answer back into the original equation and see if it produces or give you a true statement. Because if it does, then that means that that is indeed your solution. However, if you plug it back in and you do not get a true statement, then it is what we call an extraneous solution. It is not part of your solution. Then you will have to throw that solution out or discard the solution. So let's go ahead and plug in 5 into our original equation to see if we get to keep that solution. So when we do so, it's going to look like so. Notice I removed the x of the original equation that we were given, and I replaced x with 5 because we said x equaled 5. So continuing this process, 3 times 5 is 15. 15 plus 1 is 16. Square root of 16 is 4. And 4 plus 3 does give me 7. That does check, so therefore 5 is my solution, and that is answer choice D. Okay, that's it for this review. I hope you found it to be helpful. Stay positive, stay focused, study, and make it happen. But most of all, thank you for watching math videos on PowerPoint tutorial with Dr. Speights. Please like, share, and subscribe.